Hello, everyone. Welcome to the April 7th, 2020 VOLTA TST meeting. This is also the VOLTA, also known as the VOLTA All meeting, or just the weekly VOLTA meeting. This meeting is going to be recorded and posted to YouTube. Just letting everyone know that. I'm taking over this meeting going forward as Julie has had other responsibilities and is inside AT&T and won't be running this meeting going forward. So if there are topics or other things that you'd like to discuss, please bring them up to me, Zach Williams, and I can add them to the agenda for future meetings. So with that, let's get started. So the 2.3 release is in progress. The release has been created. There's documentation on how the release process went that was covered in the last week's meeting. Also, I've been actively working on doing documentation updates. The documentation site is going to look a little bit better than it did in the past. I've been actively working on improving all of the different pieces of documentation. So once this gets committed, I could really appreciate people taking a look at the documentation within each individual repository that makes this up. Right now, this is also being versioned, so this would be the branch or the actual version of that gets released, the VOLTA 2.3 branch. So I've been making patches towards that. I'll probably be requesting help for people who have more knowledge on specific areas to improve mainly the README files in each repo. Does anyone else have anything to say about the release? I know we've done a 2.3.1 of the main VOLTA chart that fixed some bugs. But hopefully we'll have a more formal release announcement later this week once the docs are ready.
How are we going to number that in the chart as 2.3.0 has been taken? Is just going to release as a minor revision of that?
Yeah, it's going to be released at 2.3.1, a patch on it.
Okay.
Okay, and this meeting also is going to absorb the stabilization meeting. So I have a probably recurring item, David's stabilization quarter. So David, you have mentioned an issue with RW core restart.
Yeah, actually, Saurav brought this up to my attention yesterday. All the failure tests, if you will, the restart container tests, seem to be working except the read-write core test. This test brings up VOLTA, brings up a device, enables it, gets it through authentication, then scales down the core, the read-write core, to 0 instances, back up to 1. During that, OF agent goes up and down as well as ready, not ready, or not ready, then ready. And then it adds Volt access in ONOS and waits for DHCP. As it stands right now, that last bit after the core restart happens, DHCP never comes through. So this would be an issue. And I will open a JIRA on this. I don't know if there's a JIRA on it right now. I'll open a JIRA on it later today and put a log file with it. Something that, in my opinion anyway, needs to be lifted up in terms of priority, as if we can't restart certain containers, that's a significant issue. The other thing, I went back and forth with Saurav on some of the other restart issues. If my understanding is correct, and Saurav, please correct me if I'm wrong, some of the restart tests, what they do is they bring up a device all the way through DHCP, restart a container, and then essentially go bring up a device all the way through DHCP again. So it's a full cycle on both ends, or both sides of the container restart. I think it would be beneficial for those tests that don't already do it, do the restart in the middle between EA poll and DHCP to see if we get continuity of bringing up a single device over the restart. And that's something we probably need to, if a test doesn't do that, add that to the test as well. Again, just to reemphasize, my point of view is container restarts are critical, and we need to be able to get continuity across those. So given that, once I get the log up and the Jira up, I will be posting to Slack, and hopefully get some discussion going and weed out some of these issues.
Okay, thank you. Yeah. Okay, thank you, David.
Is that I
Yes.
think this discussion is related to the second to last point. So if you want to bring that up.
This to the thing. Okay. Okay. So we also have two presentations today. One was on model simplification, which Kent was going to lead, and then Hung Wei had a presentation on tracing in the VOLTHA microservices. I think this is the discussion of this Jira item. Is Kent on?
Yes.
Alrighty. I'll share this. Did you want to start?
Sure. So I've been working on changes to simplify the model as much as possible. There's a bunch of stuff in it that was built for reasons I don't know, as well as for HA. And there's a lot of code in there that isn't really used. After looking through it for a while, I found that there were two types of calls, two ways that the model was being used. One was that it was being used for callbacks. So basically to register and get a callback when some particular field in the model was updated. So not just like, a device was updated, but like device state was updated, or this particular field was updated, and be able to get a callback for that. And then the other thing the model was being used for, and is its primary purpose, is to write to the database, read from the database. It is the route from the VOLTHA core through to the database. So I noticed that there was all this complexity involved in how the model was built currently, and basically realized that if you remove the callback functionality, all that's left is standard create, remove, update operations, like just very simple pass through to the database. And that's pretty much all the model handles today. That's all it's used for. So I submitted, the first patch was basically to try and remove the callbacks, remove the existing usages of the callbacks. There's only 4. 2 of them are pretty much unnecessary because we're not using HA, and the other 2, I went ahead and replaced them with sort of direct calls through. So whenever that state is updated, you just make the call through to what the update would, to what the callback would have been. Once that was done, all that was left was very simple calls through the database. So I was able to strip out 95% of the model code and reduce it to 3 files. So I kind of wanted to get community buy-in for this because it's a pretty major change and it removes some functionality. And you suggested that I bring it up here. So questions, comments, and we can discuss from there.
So you said it was used by HA. Do we have like an alternate HA solution that we're planning, or does this move us into the situation where we won't have an HA solution?
So I personally have ideas for how I want to do HA. It was used for our particular version of HA. I don't know if it's useful for a general HA. the only real purpose for it was that if something was changed in the database by another core, then you could be updated for it, right? So if some other core is writing, I need to know that the state in the database has changed, and I need to be notified. I think if we move forward with HA, then the in quotes correct way to do that would be to sort of lock who has access to things, so that you can't get a write from both cores at the same time, and sort of you get to know who's in charge of things, or direct core-to-core communication. There's many ways to do it, and it's this particular piece seems to be just a holdover from the specific way that it was done before. If we really need it, we can re-implement it, but my vote with this has always been to simply remove it because we're not really using it today.
And it's also unclear that we're going to do HA in the future, right? Versus kind of one idea is to say, look, a core and an OF agent are responsible for an OLT. If there's a problem there, it'll fast fail and restart, and we won't lose the data plane. Again, that's the condition. We don't lose the data plane connectivity. And we limit kind of the effect of a container failure and just deal with a fast restart, as opposed to try to have the read-write core have HA. So there are other ideas kind of to tackle the resiliency of the system over failures and restarts versus implement HA. That might be simpler to support going forward.
Yeah, I think I sort of like the fast fail and restart idea better. But of course, it depends what our demands are and how quickly we need to recover.
Right. It basically comes down to a question of should VOLTHA be something that is very small and you deploy many of them, or should it be something that is very robust and larger and you sort of deploy one of them for many OLTs? And that's an open question. I think in recent discussion, we've been leaning towards the fast failover and make VOLTHA really small.
Just a few comments. All the data that we have in the model at this time, the complexity is really due to the HA model that we chose before. Its main aim was really about callbacks and for the two cores to coordinate among each other and for one core to take over if the other one failed. Given that we are no longer using the compare mode, then it makes sense to remove the model because it's way too complex for what we are trying to do now. That said, the callbacks, we could just remove the callbacks and stick the way that Kent did it, in a way like before. What we have was, for example, if you have a process A making a change to the data, it will just make a change to the data, irrespective of who is going to act on that change. So you could have one process listening to that change, or you can have multiple processes to listen to that change. And with the change that Kent is doing, the process that is making the change is also the process that is determining the action that needs to happen. So it's really a one-to-one. So there's a change there, but based on the requirements that we have so far, so it fits that model. If we have a change of requirements, eventually where we need to have multiple components, multiple processes within the same core that needs to listen to a change, then we'll need to find a different approach to handle that.
Yes.
My gut feel is that should we end up in that scenario, Ken, we can find a way to handle it later, right? Right now, I think I'm very supportive of the things that Ken is doing to simplify the code base.
Thank you. And Ken, I agree. I guess I agree, and we've discussed this sort of back and forth quite a lot. It's good to be on the same page at the end of the discussion.
Is there a use case where multiple process can want to listen to the change? I mean, what's the use case?
There's definitely cases where we don't have a specific use case today in this particular place. I can see lots of hypothetical situations. Sorry, I may have stolen that from Ken.
You can have situation where, for example, a point get added to a logical device, and that could trigger get added to a device, and that could trigger creating a logical point, and also that would trigger an event being sent to owners. So, but those kind of things we can, the way it's designed, we can serialize those things. So it's kind of like they are not blockers per se. So in the future, we may have something like that, but not really now.
Okay.
All right. The other thing I wanted to discuss surrounding this is I opened a new epic in Jira for refactoring in general. Yes, VOLTHA refactoring, and basically just that I'm looking at doing more things like this. There's more things. I'm focusing on the core for now, but I'd like to have something rock solid and smaller, faster, easier to maintain. So just sort of that. I want to warn people that there might be some code churn, things moving around, but hopefully it should be easier to maintain moving forward. And that's it. That's all I have. Thank you.
Yeah, I'm all for the creating this epic and also simplifying the code base even further. I seem to remember at one point that who was it? Stefan. I can't. Is it
Yep.
Stefan? Right.
Yeah.
Had mentioned there was a pretty complicated way of storing things into etcd. Maybe I'm losing the context here, but
that's it. You're right.
various hashes and things were taken for simply storing objects into etcd. Did that get simplified, or does anybody know what I'm talking about?
Yes.
Yeah.
The hashing was used way back when there were multiple revisions of things, and the hashes of them were used to keep track. That I don't believe that part was actually being used currently, but it was still in the code, and that has been removed. Yes, that's part of these changes.
There was to answer your question, Saurabh. There's two phases. In VOLTHA 1.0, everything was stored as a hash. So if you take a device, they were built as a tree, and every branch in that tree had a specific key in the KV store with a specific hash. For example, a point will have its own key and a set of hashes associated with that. In 2.0, we removed that because it's since we're loading data from the KV store more often than we used to do, at least when we started the HA, then we decided to store the entire data, device data, as one blob. It's it's a binary blob in protobuf instead of storing every single element in that tree. So that was really the complexity in 1.0. And in 2.0, we just store the entire data as a blob. And that still remains today.
Okay, thanks.
So Kent, would looking into the Kafka inter-container bus, would that be under the radar of your simplification effort? I know people have talked about refactoring that or removing it or changing it to gRPC, although that would be a large API change.
So it falls under the umbrella of this epic for sure. I don't know when we want to tackle something like that. I'm all for doing it sooner rather than later, but at the same time, that would touch many components, and
yeah, that's a good point.
That's a much larger change to make. Replacing things with gRPC, I think we probably want to do that after the ONU adapter has been rewritten in Go. That's my current feel on it, but I'm not. If people are all for removing it, things would probably run faster if we made that change sooner.
But I don't think moving to gRPC is a priority right now, because I don't think Kafka itself is creating performance problem or really any kind of problem.
No, it's more just that things will run faster without it if it was just a direct pipe from the adapters to the core. But it's just an optimization simplification. It's not like, none of this is high priority in some sense, right? But it's also, we can't just ignore it because otherwise it's
no, agreed. But one thing that probably fits in that category is to think about how we'll migrate data between two different versions of VOLTHA for software update. And I think that has a much bigger priority than moving to gRPC.
I believe so, but I'm not the one to make that call.
Yeah, that's right. I mean, for 2.4, which we're targeting, end of June, I think we have a set of priorities. And so, and we will be discussing that over the next few weeks in a smaller setting. And then at the end of the month, our face-to-face that was supposed to happen in Berlin now is online. So there's an agenda that we are coming up with. So by that time, we should have a pretty good idea about what we are supposed to deliver in 2.4 and then for the rest of the year. So 2.4 will be pretty tight with the stuff that got left out of 2.3. So it's possible that this move to gRPC may have to wait. But we'll see.
I guess, yeah, my issue about gRPC, and I agree, maybe it needs to wait till up to 2.4, is if we're not using Kafka as a message bus in terms of broadcast or one of N, and we're really just using it as a point-to-point API invocation, then we're using a technology not really how it was designed, and it's overkill for what it has. So there's a general simplification in terms of supporting an application with fewer things. And that's kind of where I see a gRPC simplification coming in. Regardless of the performance implications, it's just easier code to maintain if every component's got the same way to communicate with another component. That being said, in priorities for 2.4, kind of, yeah, they may be set.
Well, David, the point is also what Matteo is working on with the multiple ONU adapters. Yep. That makes fairly good use of Kafka. So, as we said, I don't think it's a priority at the moment. We see
I thought he was actually doing a topic per ONU, which means you're doing
Yeah,
point-to-point
that will
communication.
actually work fairly well with gRPC too.
Okay.
Yeah, but I agree. Priorities are a different issue.
Yeah, I guess my objection to the inter-container bus is, you know, I've reviewed a few patches where people have added new APIs, and it's just, it feels like 10 more levels of code that something has to go through to plumb an API all the way through. It's, you know, it's sort of a unique to us implementation, the way we pack arguments together, and
Well, isn't it basically gRPC over Kafka is kind of the way to look at it?
Yeah, but we've got this thing where we pass an argument list. It's just, it seems unique to us. I mean, the encoding is protobuf, but some of our layers just make for implementation and maintenance, additional work. Though I agree with everyone else who says, you know, it works, so it's not necessarily a priority to remove it.
Yeah, one thing I will say, it's like we have something that works today. Unless we find something like a really problem with it, then we should change it. Because don't assume that moving away from Kafka into gRPC, that will be a small amount of work. It won't.
I agree with that. But I would say that removing Kafka simplifies the overall implementation, which has some benefits to ongoing support, development of the application. But I agree, it's not necessarily a simple change.
Okay, thank you, Kent. Next on the agenda, we had a presentation from Hung Wei on tracing in microservices in Jaeger, but I saw somebody added this etcd consistency issue here.
Oh yeah, that was me. Sorry, I missed to put my name there, Girish.
If this will be quick, I'd like to do this before we do the larger presentation.
Yeah, sure. So in one of the failed test jobs on Jenkins, I was seeing that there was a possible consistency issue with etcd. So two subscribers were trying to install a flow almost simultaneously. So the access to the resource pools are actually protected by lock. So when one user was trying to query a flow ID resource from the resource pool, the other user was blocked. But as soon as the first user completed the request, the next user, got the same resource as well. So that made me believe that there could be consistency issues with etcd, but although etcd documentation says that it's pretty consistent. So once you get a response from etcd, you can be sure that the data is written to the database on etcd. So does anyone know more details about this before I go ahead and start digging more into this issue? So just wanted to bring this up.
What level of consistency is our etcd configured for? Because I thought it was more of the eventual consistency, which in that case, a get after a put might return different data.
I'm pretty sure etcd consistency isn't eventually consistent. It's strong consistency.
I thought it had levels. I thought you could set it configured differently.
You should be able to set it different levels. I don't know what the default is. I believe at one point we set it to make sure it's full consistent, but it may be like eventual consistency.
So we don't run etcd in clusters, so I don't think setting to eventual consistency makes sense at this point. So where would that setting be?
So the other thing I wanted to mention here is you may want to wait. Hopefully the changes that I've described to the model will go in today. You may want to test with those changes.
Girish, which component are you actually seeing this?
On the adapter. The adapter interacts with the KV store for resource allocations.
Okay, so that has nothing to do with your change account.
Okay.
One thing I've noticed before, and that was a while back, was I was getting into a situation where you had something very similar where you're doing a get and after a put and you are getting the previous data. At that time, I saw that there was some lock missing in the model itself. So I associated that with the model, but it could be maybe it was etcd as well. So in my case, I move a lot of things in cache so that the next method doesn't really require the data from etcd because what is in memory is always up to date. So this is what we will get. So maybe there is an issue there if it's too quick with etcd.
Girish, is there a Jira issue for this?
No, not yet. I was still investigating. I could create an issue, Jira for this one. I saw this issue a couple of times. So and the code, seemed pretty simple. There wasn't too much going on there. It's a simple lock, and access the KV store and then unlock. So
this should be able to be tested in the small too, right? Just create a little app that connects to etcd, does a put, does a get, right? You should be able to see if we can replicate this outside of Volta.
Yeah, that's a good idea. I could try that. But again, I wanted to go back to my previous question. So where is the setting on etcd, which says, which configures the consistency model, eventual consistency or strong consistency? Where would that setting be?
I can't remember it. It's been a while, but I'm sure you can Google it.
Yeah,
but if you're running with only one container of etcd, then it shouldn't really make a difference, right?
Yeah, you're right.
But also, the goal is to not run just one instance of etcd, right? Now, in our test, we may be using Volta minimals, so only one container shows up, but the idea is to run etcd in a cluster, right?
Yeah, that was my same question. I'm kind of worried that we're running etcd as a single instance. The whole point of having the consistent database is running in multi-instance with fault tolerance. And that's why the whole point of writing the data there. Otherwise, why do we run etcd at all? So
but there are performance issues the minute you say I'm going to run a cluster of etcd in full consistency.
But we have to run with those performance issues because otherwise you have failure of etcd and failure of the whole data, and everything goes down. So
are we saying that not only we need to run etcd in the cluster, we also need to have full consistency?
I think regardless of a cluster, I think we want full consistency. What I'm hearing is we want full consistency, so that if I do a put and a get immediately after it, I will get the data that I just put.
Yeah. That was the point. It was not about running etcd as a single instance. Even if you run into multiple instance cluster, I wanted the strong consistency model.
Yeah, and with that, we will have a small performance hit. I don't know how much it is, but we will have them.
Okay, yeah. Can get back to that later.
There might be something in the etcd cluster chart that sets consistency. I don't know. I haven't looked at that in the chart for a bit.
I will take a look at that. Thank you.
By the way, I have one. I believe we use the etcd operator in our deployment, and I just know that etcd operator is depreciated, is unmaintained. So, do we need to migrate to other etcd solution? Because the one we use is off-maintained.
etcd deployment is actually an exercise for the for the deployer,
Okay.
right? We're using operator. We should probably change if it's not being maintained, but it's whoever actually deploys Volta has no requirement to deploy etcd with operator. They could deploy it any way they want.
Okay, got it. Yes, thank you.
So is there a Jira, a ticket to run etcd in a multiple node, multiple deployment scenario? Because I think this is very important, and if we never tested it with the current code base, we probably should.
Kind Volta in full mode will deploy an etcd cluster, I believe, as it will deploy multiple Kafka cluster too.
I believe we also do have a test that scales an etcd instance in a cluster down and then brings it back up. I think Hungwei actually implemented that test.
Yes.
As I recall, it scales it down but doesn't remove the quorum, because as we're using etcd, at least etcd operator, once you remove the quorum, etcd operator just chokes. Not chokes, it by design doesn't restart.
Okay, if there aren't any other comments, Girish, if you'd create a Jira issue so we could track this, that would be great.
Yeah, sure, will do. Thanks.
And the next item we had was a presentation from Hungwei on tracing using Jaeger through the Volta microservices. So I'm going to transfer or give presentation rights to Hungwei.
Yeah, I can share a screen here.
Go up in my share.
Okay, so can you see my screen?
Yes, we can.
Okay. I'm Hongwei Chu, comes from the Open Networking Foundation, and today I will share the tracing in Volta microservice with Jaeger. So I will talk about what is tracing and what is Jaeger and how it looks like when we integrate the tracing in Volta. We all know microservice environment provide a powerful architecture for people for deployment, but it also increases the complexity and difficulty for people to debug, because all the message and all communication are not in memory now. They are cross-processed in different way, like a gRPC or HTTP. So we are not able to use the tool like a GDB or the perf to do some profiling or see the function code trace. So it's very complicated for people to debug if you have some problem in microservice environment, especially if you want to know which operation is the bottleneck. Distributed tracing just wants to solve this problem. So they want to provide a solution to describe and analyze the cross-process transaction in the microservice environment. Provide a portal, provide a GUI, or provide some data for people to know, okay, I have the workflow and which operation is bottleneck, so I have the clue to know which operation should be improved. And 10 years ago, 2010, Google published a paper to introduce the concept of the the distributed tracing. And in this paper, Google described the use case and some basic usage and some how to do distributed profiling and some term definition. But the distributed tracing just a concept. And now there's a project just called Open Tracing. Open Tracing want to support the distributed tracing for people. Open Tracing is a comprised of the API specification, framework, and libraries. So you can easily to do the distributed tracing in your microservice environment. Just modify your source code to use the library provided by Open Tracing. And Open Tracing provide support different language like Golang, Java, JavaScript, Python, C++. So, but one thing we need to know is Open Tracing is not a software you can just install to your microservice environment, because we want to know the function level, we want to know the low level of the operation to know which one is bottleneck, we need to modify our source code of our application to work with the library to report something. So if we want to use the open tracing, okay, you need to choose the language you want to use and start integrate with your source code. And here we will talk about the basic model of the distributed tracing. In the left side is a very common use case in the microservice environment. It's a very common workflow. We have the client, just like the HTTP client, maybe the tool, like a curl or wget. And we have the web server here. And we also have some service, the backend server, different service, and we also have a database. So a common workflow will be someone send up the HTTP request to the web server, and the web server will send out the message to different service. And in the service, they will just call the database to get some data, do some SQL queries, and then we'll reply to their caller. So this is a workflow. But in the distributed tracing model, we want to know which one is the bottleneck. So we will use the different way to see this workflow, just I show in the right-hand side. It's a type-based series graph. In this graph, each operation is just like a box. And we have the most important part of this graph is the time step. In each block, defined by the two time steps, the start and the end. So if we could build up the graph like this one for our microservice environment, we should be able to figure out which one is the bottleneck. And when the problem occurs, we may be able to know, okay, which operation takes too long time and which operation need to be improved. For example, in database, maybe it just takes 10 milliseconds, but in a whole web server operation, it takes 1 second. So we know, okay, maybe some internal process takes too long and we have some space to improve the whole process. And now we talk about the basic unit in the open tracing. In the open tracing, we have the two basic units called a trace and a spans. A trace, just like the workflow, it includes multiple spans. So in a trace, there will involve multiple service and multiple operation. Span, just like the operation. Operation could be some internal function call. So I call that function, or I do some remote procedural call. I send some network traffic to other service with the Kafka, gRPC, or HTTP. And in the span, there are 3 or 4 fundamental attributes here. The first one is span ID. So you can see in the top yellow box, it's called span A. And the second attribute is the trace ID, because we would like to know all of this span belongs to the same trace. So we should be able to draw the graph like this one. And the second one is the parent span. Just like I mentioned in the left side, we have the caller, we have the callee. Someone will send request, and someone will send reply. So the span also has a relationship like this. We have the parent span. So you will see the parent span of span B is the span A. It means a span A will send request to the span B and will wait the reply from the span B. And in this case, span B will send request to the span C and the span E. So span B will be the parent span of span C and span E. And the last attribute of the span is the time step, because we want to know the time period of each operation. So we need to know the start and the end time step of each span. That's the basic unit in the open tracing. So we talk about the span and talk about the trace. And the third one is called span context, because in a microservice environment, all of our service might be deployed on different hosts. If we want to build up the graph like the right-hand side, we need to load all span with the same trace ID. And maybe you should also know your parents span ID. So there is an object called span context. It includes some key value data and also the span ID and trace ID. So for example, if I would like to send an HTTP request to other service, I need to propagate the span context inside my HTTP request. So the server, the receiver can get the span information and based on those information create another span. Just like this example. In the left side is a client and he want to send some information to the server. So first of all, he will create a span here because he created a first span. This span doesn't have any parent, and he also created the trace. So he will have the trace ID as well as the span ID. And this client need to inject the trace ID and span ID into the span context and then into this carrier. In this case, the carrier is an HTTP request. Other example may be like the gRPC or Kafka. Okay, so in the server side, once he receives the HTTP request, you need to extract the span context from the HTTP data and then get the trace ID and span ID. So in the server side, you need to create another span based on the client's span ID. So the client's span will be the parent span of the server side. And the span in the server side will use the same trace ID. So in the database, they will know, okay, those two spans belongs to the same trace. So we will be able to build a graph like I mentioned here, the time series here. So it's just the basic unit in the open tracing. We have the trace, we have the span, and if you need to propagate some information to different service, you need to pass the span context. Okay.
A quick question for the distributed systems, and if you're going to talk about this later, that's fine. The span, does it also include an indicator of the container it came from in a microservice environment as opposed to just a function? So I could tell it came from a specific instance?
Actually, both. You can do the function level or do the container level. It's just by you because you need to upgrade the library for you, so you can do everything you want. You just call some function like, okay, I want to create a span, I want to report a span or something.
Okay, thank you.
You can add as many labels as you want to a span. For example, you can add the device ID in the case of VOLTHA or the phone port number or really whatever you want. It's a key value thing you can add to every span.
Okay, thanks.
Okay, so the next one I will talk about Jaeger. And Jaeger is a distributed tracing system and released as open source by Uber. And his is a open tracing implementation solution. It implements the API specification, also with some powerful feature like the GUI portal, and also support different backend storage. Because sometimes you need to store the span and trace in data, but in they support different storage like the Cassandra, Elasticsearch, or in memory. And in my demo environment, I just use the in memory. It's enough. And Jaeger is a project in Cloud Native Computer Foundation. And interesting part is a graduate project. As I know, there are only maybe 9 or 10 projects is a graduate in Jaeger. In CNCF. And Jaeger also provide also support multiple language like the Golang and Java. So in my demo environment, I use the Jaeger with the VOLTHA, try to introduce the open tracing in VOLTHA and to see how it looks like. Here is Jaeger's architecture. There are 4 components in Jaeger architecture. The first one is Jaeger's client. Jaeger's client is the library you need to use. You need to integrate with your application. So for example, if I take the BBC is implemented by Golang, so I choose the Golang's Jaeger's client, and I integrate them together. So and in your environment, you need to install the Jaeger's engine, because Jaeger's client will, once you create a span in your application, you need to report the span to the Jaeger's controller. You need to report the start timestamp, the end timestamp, And you also need to report the information of the trace and the span. Those information will send to the agent first, and then agent will send to the Jaeger's collector. And you will see there's a red dashed line here. It means Jaeger's controller will be able to configure some behavior for each Jaeger's client. For example, like a sampling strategy. You can configure the frequency of your sampling, maybe like the probability or constant or rate limiting. And in the right-hand side, there's a portal, the UI, and there's a component called Jaeger's query. Jaeger's query will get the data from the database and provide a basic portal for you. And they also provide some service API here. If you don't want to use their portal, you want to set up your portal, okay, they provide a gRPC or HTTP for you. You can set up your own portal, or you can use another internal program to retrieve the data and to do some monitoring or along. So one more thing about the agent and the collector is how you deploy the agent and the collector into your environment. The basic way is just deploy one agent in your microservice environment. But in this case, all traffic will go to this agent. So the production way maybe deploy the agent as a daemon set on each host. And for the collector, you can also scale out the collector from 1 replica to 2 replica or 5 replica. They have the collector cluster to make sure the data is consistent in their base. And in Jaeger's query, they provide a basic symbol portal for you, and I will show how the portal looks like and how can we use the portal to do to see the graph I mentioned above. In the Kubernetes, Jaeger provides some operators, so it's very easy to install the Jaeger to Kubernetes. In my demo environment, I don't use the Kubernetes, I just use the Compose. I would like to make everything simple. So I use the special container image provided by Jaeger, just called all-in-one image. In this all-in-one image, it includes the agent, collector, and the portal. So I don't need to worry about how those components communicate because they are in the same container image. They can communicate with the local host. And I use the constant, the sampling frequency to report all message. And you have the other choice like the probability. And I believe the default value is 5%, or you can use the rate limit to limit the trace per second. So it depends on you. And I would like to use the open tracing in VOLTHA to see the VOLTHA control enable and create. So I modify the following project: the VOLTHA goal and VOLTHA library goal and BBC and OLT. And okay, so let me so in my environment there were 4 components here. The left one is the VOLTHA cutter, just the command line tool will send request to the record. And the record, I will create the span. This span is the first span, so it should be the root span, no parent. And I will propagate the span information, the span context to the Kafka topic. So in Kafka topic, there will be something like a span ID, the trace ID. And in the OLT, the OLT is a Kafka consumer. So you read data from the Kafka topic, and you will get the span information from the span context, and you will create an span here. This span is a trial span of the span in record. And then OLT also a gRPC client. So I just pass the span context to the gRPC client, and gRPC will pass the span context to the BBC. So I would like to see if we could know the open tracing in this workflow from the Kafka to the gRPC. Maybe we can know more something, and we can learn more to see what's the bottleneck in our workflow. So here is the demo. It's the Jaeger's portal. Can anybody see this portal?
Yeah, we can see it.
Okay, so in this portal, there's a service here. A service just like a microservice, like a container label. So we have the BBC, we have the OLT adapter, and we have the record. And the BBC here, you can see there are different operations. And you can also notice the naming of those operations are very different. The former one is created by the gRPC Open Tracing library. There's a library help you to integrate the gRPC with Open Tracing. It's very easy. So they will name your operation with the path of your gRPC endpoint. And the later one is the function. Is a function called function call operation is created by myself. So I just use the function name to name it. So we can see some example here. For example, get a device info. For each operation, you can see how many checks about this operation. Okay, let me trace the that one. So you can see for this operation, there are 20 checks of this operation. And in each chest, there are 2 spans here. So let me see here one. Okay, maybe this one. In each chest, we can see how many service and the depth of this chest and how many span in the chest. And we could know, okay, this chest totally is 2.52 milliseconds. And here we can see the detailed information of the span. The first one is it's a gRPC client. The gRPC Open Tracing library will help you to add some information here. The tag is a key value, so you can add anything you want into this span if you want to know more about this span. For example, if you want to enable or create some device, we want to know some device ID, so you can pass the device ID to here. And in this case, it's by the gRPC client, so we know the endpoint, and we know it's a client. And this one is a gRPC server. But by default, the gRPC Open Tracing library won't help you to add some information here. So if you want to know more detail, maybe you should not use the library here. You should inject and extract the information by yourself. And in this case, we could see, okay, the gRPC server just take 0.01 millisecond, but the whole trace takes 2 milliseconds. So maybe we could know, okay, most of the time are the round trip time and the networking packets. And let us see the other more complicated use case, the BBC. You can see here, the active ONU. In this operation, there are 3 services here and 12 span. So we have 3 services. We have the rewrite cover, we have a OLT, we have a BBC, and we have a totally we have a 12 span. And we know the rewrite cover is a Kafka producer, and I will send some traffic to the Kafka topic. So I just modify the rewrite code and the VOLTHA library code to support the open tracing in Kafka. So I will invoke RPC, and I can see the topic, the to topic, and reply to topic, some data here. And in the open OLT side, once he receives the information from the Kafka, it will send a gRPC client, sorry, send a gRPC request to the BBC. But we all know the rewrite code just wait the act of the Kafka. They won't wait the whole operation. So you will see the rewrite code, the time period of the rewrite code doesn't cover the whole span. Sorry, I see this question. Okay, if we use the gRPC Open Tracing library, yeah, he used the gRPC context. So you need to, I'm not sure, but you may need to pass those tag information to the gRPC context. Okay. So let's go back to this dashboard. And you may also need to notice there's a gap between those 2 spans. I named a span by the function, so you can see this span is created by a function in some object called device handler. And the function name is adopt device. And the other function is called active ONU. And you will see there's gap here. The reason is I did not pass the span context to all functions in the open OLT. So if you would like to monitor all functions in your container, you need to pass the span context to every function you want to monitor. So that will be a bigger effort. It just depends on your requirement. If you just want to know the container level, okay, maybe just focus on the gRPC, HTTP. If you want to focus on the function level, you need to pass the span context to every function you want to use. Okay, so it's just the basic idea of how to use the open tracing and the Jaeger in our VOLTHA environment. So you will see the time of each operation. So let me give a summary here. Distributed tracing wants to provide a solution to describe and analyze the cross-process transaction. And in open tracing, there are three basic units, trace, span, and span context. If you want to monitor the span with cross process, you need to pass the span context into your carrier. The carrier should be like a HTTP or gRPC. And Jaeger and open tracing not just a software. You need to integrate them with your source code, your application, and based on your requirement, if you want to do just the container level, okay, you can just focus on the client and the request. But if you want to deep into the function level, you need to pass the span context to each function and to report the span information to the Jaeger's controller. Okay, so that's all of my share about open tracing and Jaeger in VOLTHA. Does anyone have some problems?
So this is good. Go ahead, Scott.
I was just going to ask a question, and that was earlier in the presentation you showed where you were instrumenting sort of when you enter and when you exit a function or a block or a span. Is the difference between tracing and logging that you're only doing this on entry and exit of a functional unit, whereas logging would, be emitting messages throughout for various important steps, or does this have more overlap with logging?
Can you log to a span is a good question.
Yes, yes, you can log to span. Let me find some example here. For the gRPC side. Sorry, I use this one.
So you can add as many information as you want to a span, but it's suggested not to add too many information, so not to add all the logs to the span, because the span would go over the wire and you're just spending a lot of data and will possibly make everything slower because you are congesting the network.
Where I saw that is kind of complementary. It's not necessarily log to the span and carry it with it, but open tracing is creating span IDs, it's creating trace IDs. We can leverage this in logging so that when we log messages, we can also log the trace ID or the span ID. And so we'll have open tracing for kind of the entry exit point tracing. And we can also associate that to our log messages, because now we have the goal of seeing an end-to-end transaction in our logs over multiple containers, multiple log files.
So
I think using the same IDs is going to be key.
Yeah, I think that's kind of where I was going with this, because the people working on logging are investigating the similar problem, which is, how to associate all relevant log messages with a particular request, as that control flow passes amongst multiple components, as it goes request all the way through to the adapter and then reply all the way back up to the core. So it seems like there's considerable overlap, and if we could leverage some of these features that Jaeger is providing, maybe it prevents us having to implement those ourselves.
Yep.
Yeah.
So, one question off of an earlier comment. Somebody said that when you use this, everything's going over the wire. Yeah, I assume that's a external connection to open tracing, like to an open tracing API, not over. How is this built, I guess?
Well, there are two sides of it. One is, let's say, out of band, because you are sending all these spans to Jaeger collector. But you are also sending information with the context with each request. So you don't want to put too many information in that request, because, for example, if you see the ONU ID and the serial number in that span, those information will be sent together with the context all the down the call stack and then over gRPC to activate ONU. That's why they suggest not to put too many information in the context.
So in the context, you basically just want to have span ID, and you can put it all back together later.
Yeah, I mean, if there is a unique key that helps you identify a thing in the stack, I think that's fine. You just don't want to start putting every single parameter you have in the function in the context.
Makes sense.
So there's a little bit of subjectivity here, right? What's important to add?
Yeah, it's a trade-off. How many more data do I want to send on the wire? Because I can accept my request to be a little slower if it makes my life much easier in tracing it. But I don't want to double the size of my request to have all the information there while I can get those information from the logs.
Yeah. And there's nothing to say that you couldn't pull this data, the data from this together with the log data into an Elasticsearch database to come up with something more complete.
Yep.
And do that on the back end.
Yep.
What about running without the Jaeger components? So I can see, again, I don't know what the performance hit is running with this, and I know it was a UDP connection, but it might be that I want to have my, not deploy the Elasticsearch database, UI, all that of Jaeger automatically, right? I just want to keep that off, but I want to have all the code ready to be Jaeger. So if I did start that up, it could start connecting. That makes sense? Kind of.
Yeah.
Is that possible?
Yeah.
It's possible, yeah.
Okay.
Yeah, so the library for Jaeger keeps a buffer of messages in memory that you can configure. And then if it finds a Jaeger server, just send all of them to the server. It's not that discarding from the tail of the queue.
And if I set that to a certain, if it goes over the in-memory threshold, it just drops the oldest?
Yeah.
Yep. Yes.
Okay.
So is the Jaeger server itself, is that a scalable service? Is there concern that we could overwhelm it?
Yeah, it's a scalable server.
So they run it in production at Uber. I don't think we'll overwhelm it. If we do, we are doing something wrong.
Also, there's all
sometimes we
those,
do things wrong. Yeah, but yeah, it should be able to handle us then, I would think.
and there are ways to make it so that it doesn't trace every transaction. You might want just a percentage wise, or there are other ways to rate limit it so that you don't overwhelm it.
What's Uber using as their persistent store for this?
I'm not sure.
I think it's like Elasticstack, but I'm not entirely sure.
So if you're like planning to include it as part of the even the production binding, right? So it should be possible to probably dynamically switch it off and on, right? Based on some runtime arguments.
Well, if I understood correct, the client side can always call the Jaeger functions, inject context, and if there's just no server, it'll just not send the messages. Can we go back to kind of the deployment diagram in the presentation?
This one?
Yeah, so for instance, everything from Jaeger collector over to the right, I don't necessarily have to deploy.
Mm-hmm.
Right? If I wouldn't get the benefit, but I don't necessarily have to deploy it.
Correct. Also, Jaeger agent, you don't need to deploy it.
You mean without the collector, just the agent?
Yeah, let's say I'm going into a deployment and I don't want to run Jaeger all the time, I just don't want to deploy it. I have a customer that says, "Great, I'm glad you got Jaeger. I don't want it."
Yeah,
I don't
then
want
you
to
just deploy You just deploy your application that is instrumented with the Jaeger client, and that's it. Your Jaeger client will, you can even configure in that case your client to have a queue of 0, so it doesn't keep anything in memory.
Yep.
And that's it.
The Jaeger agent is part of the container though as well, so it's part of the process.
Part of a
Can be
container. Yeah, it's part of a container.
It can be deployed in many ways. It can be on a per host basis, on a per container basis. You can have a single one for your entire cluster. Pretty flexible.
Okay. Okay.
Yeah, my general thought is that it shouldn't go in the same container as the application, but that can be debated.
Almost like you could put it as a sidecar almost type of thing.
Yeah, I think generally in Kubernetes is deployed one per node, one agent per node. But okay. I was reading something that if you have some very IO intensive application, you may want to deploy it as a sidecar and dedicate it for that particular service.
One per node seems reasonable, or even one for cluster, like because we're not sending that many requests, right? So
yeah, no, it really depends by the size of your cluster. In our case, one per cluster would probably do it. In the Uber case, when they have a cluster with 200 nodes and 10,000 services, they may need something more than that.
All right, makes sense. Cool.
Okay, and here's another example of the gRPC OpenTracing library. In this case, the OLT adapter will send a gRPC client to some server, but the server I did not modify with the OpenTracing, so I will only show the client's information here, and you will see if in the gRPC request, if I get some error from the reply, the library will help you to add the log here, so you can see a PC error on available systems not ready. So you can add some log into your trace. Okay, that's another example here.
Okay, yeah, thanks for that example. That's interesting. So that log that you added then there, it does not it's not carried through the remainder of the trace. That's just an emit it as information, and then I guess what I'm saying is the overhead is just sending that through one time, that one log message, then it emits it into the persistent store, and then it's done with it.
I think so.
Yeah.
Is that sent on with the request, or is it just sent out of band?
In the request. No, I think the log is reported by the library. So when I receive a span, I need to report the time spent of the end, and also with as well as this information to the Jaeger's collector. So it just be one-time message from the Jaeger's client library. But the tag will be the log just will be one time, and tag should be for the tag you can choose to propagate the tag of information to other service or not.
Yeah, I guess coming back to my original thought was, we're talking about rolling out this duplicate system where we'd use FluentD to pull logs out of Kubernetes logs and send them to Elasticsearch. Mm-hmm. This seems like a mechanism that's capable of doing the same thing. You can send the log to Jaeger, and Jaeger will send it to Elasticsearch. As long as Jaeger is not, as Matteo suggested, keeping these things around and adding a bunch of overhead that it has to carry throughout the entire trace. If it's just a pass through and I'm done with it, that seems, it seems like we could consider this as a logging transport. I wonder what people think about that approach, as a way to go from the containers into Elasticsearch.
I like the idea of using one tool chain and not trying to build our own.
Again, if the log here, it's not being transferred. If I jump context or jumps containers, those logs aren't being transferred.
Sorry?
Well, I'll have to go back and look. There were two ways in which you can annotate a span, and one was going together with the context, and the other one was going out of band to the collector. I need to look that up.
Right. That.
So we just have to make sure we're using the out of band version.
The other question is, if I use this for logging, and I like the idea of a single tool chain. Does that mean my logs aren't showing up in kubectl logs?
Yeah.
I'm assuming we could do both.
Yeah,
it wouldn't be difficult because we have a logging library already, right? So we just have to augment that.
Mm-hmm.
Yeah, I too would want it to go to both kubectl logs and out through Jaeger, and you would, as Ken suggests, I would certainly think you could send it to both.
And the message here is not JSON. Our logs today are JSON. How would that work and be passed through so that when it gets to Elasticsearch, I can search on any of those JSON object entries?
Yeah, we need to understand whether this the UI, right, of this would provide us that capability, right, which we get from Kibana to search based on all the elements, right, all the attributes which we have in the log, and define, right, different criteria.
So our logs are structured going into the logger package, but it's really the last step, I'm assuming, that turns them into JSON and emits them as a JSON string. You know, if Jaeger could take the structured logging directly, which we would just have to see if it could, then, you know, maybe we could bypass this JSONification of things and, you know, the need to un-JSON it to go into Elasticsearch.
And that's fair enough. The question is, can it deal with the structured logging, and on the other end in Elasticsearch, is it taking advantage of that structure?
Yeah, exactly.
Even if we had to write something custom to translate the structured logging, the structure is not difficult. You're just passing in what's effectively a renamed map. So all you'd have to do is iterate through that map and turn it into this key value form that.
But does it this? So, just want to understand. So, are we looking at the Jaeger to ingest that logs into Elasticsearch and use Elasticsearch as its backend, and then we will use its this Jaeger's API to do the analysis of the log? So I'm trying to, I think, understand the issue.
There is a desire to have logs in a searchable area, logs over all containers. And the question is, can we leverage this tool to facilitate that and get that done? I agree it's easy to convert one structure to another. The question is, in this key value log message, well, we still have to answer, is it actually just put to Elasticsearch, or is it transferred as part of the gRPC header context? And if it's part of the context, then I think we can't do that because the logs are going to be too many. The other question is, when it's transferred over and into Elasticsearch, is the structure maintained, or so that I can query against either, you know, does the tag exist, or does a tag have this value type of thing? Okay. Do we have an example of what the Elasticsearch, how I could search the log messages through this UI, for example?
Sorry?
Is it possible to do a Jaeger query against logs?
No, you can just use the tag to filter the information here. You can use the log, can only be used the tags.
So if you were query for message, for example, would that give me, because the log had event and message, I think, what it had, right?
Example component gRPC, I can use this one.
Okay. So if we went back to the example you had, though, it had a log message with it.
Sorry. This one?
Yes. Well, actually, I don't know yet. Where's the log? It said log.
Oh, you see the log, sorry. Log
Yeah.
will be get VOLTHA. Okay. So get VOLTHA, we have logs here.
Logs.
I don't
Can I query over those tags?
Let me try. Event duration. I see. I think we.
Well, could you like query for message? Message, you know, contains something like that. Yeah.
Try this one. Maybe it will be string. Wow. Yes.
And does that partials too? If I don't know if it does wildcarding there, like message equals RPC error star type of thing.
Yeah. See, I think we.
I mean, its indications are that we can search it though, which is nice.
Yeah.
It seems to be searchable. The question is, does it support wildcarding, and are things sent over in band or out of band? And that's.
And can I actually just list all the logs directly? Like I just want to stream. At some level, I want to say, show me all the logs with transaction ID X from timestamp 1 to timestamp 2.
Yeah, we have them. Timestamp
right?
1.
Or I want to, you know, I want to see just the log messages for transaction ID, whatever, right? I don't want to see this multiple kind of table-ish entry. I just want to see the logs.
Yeah, so we have the customer time range here. We can just see in the specific time span. And for logs, yeah, I don't have too much example here to show different.
From a log viewer point of view, I don't want to have to drill down every time. I want the logs.
But this is the Jaeger UI and not the Elasticsearch UI. If the data was in Elasticsearch and we went in through that UI, maybe it would have a presentation more to your liking, David.
But would the schema of the the data which is being pushed by Jaeger would match? Let's say Kibana, what Kibana expects, right? That's not right. Maybe the story is still the Elasticsearch, but the schema may be different.
Yeah, maybe.
I think some more investigation to see if this actually can be used for log viewing beyond the question of how's it transported. It's going to have to be done.
I think, but one good feature of this log viewing, which it is providing, if we can do log viewing in this, that would be good, because in Elasticsearch it becomes difficult to do the correlation of the logs, right? Unless you pass the same ID across, right? In this, I think because of the span and child spans, you could all see the complete information in the single view, right?
And I think and I think it will benefit us to use these same span IDs and whatever ID, the other ID within our log messages as well. So there's, regardless of this, if this can be used as a log viewer, using those same IDs consistently between tracing and logging will be beneficial.
Yeah, I think we need to coordinate. I think on the tracing related solution and logging solution, I think the team need to coordinate so that we use the same ID.
Yeah.
Now, for this ID stuff to work, we had that diagram that showed kind of the architecture of all of the Jaeger parts and how we would leave possibly some of them out, like the Jaeger collector and everything to the right of it. We could leave that out in some contexts. Is just the stuff on the left, is that sufficient to generate all of the span IDs and context IDs and other things that we might want to be able to use as part of our logging infrastructure? I guess what I'm asking is how many of these boxes can we leave out and still generate those identifiers that we could use to piece together a request across multiple components?
I believe the identifier are generated by the Jaeger client.
Yeah.
It would make sense that you'd be able to leave out everything but the client and like just use the client to generate the IDs. Obviously, we'll have to verify that, but that would make sense.
But there's one thing I want to mention here. You see, the client and the agent they use the UDP to talk, so it's not guaranteed that the message will be delivered. So if we just use the Jaeger for the log, maybe some log will miss because it's based on the UDP packet, right?
And that could be an issue.
Yeah. So maybe some problems, maybe sometimes there's a problem, and just unfortunately the packet, the UDP packet is be dropped for some reason. It will not be resent. So we will not see any log from the Jaeger's database. Yeah.
You are always deploying the agent inside the container. So is it deployed like a sidecar or something in with the container?
It depends on you. You can deploy the agent as a sidecar or as a daemon set. Yeah, it's up to you.
Yeah, we were saying earlier, you just deploy the agent as needed. So it could be one per cluster, one per node, or one per container.
Yeah.
On the UDP issue, I assume that whatever protocol they're using will deal with that. Will deal with loss, right? Or is this a scenario where you're just assuming that logs aren't important and it's okay to drop them on occasion?
Oh yeah.
So this also, if we use this as our only logging source, this also assumes that we are capturing all the traces. While
That's
from
true.
what I understood in production, that's not really the case. They tend to sample like 2 to 5% of the traces, just to monitor that the system is stable.
Yeah. And to be fair, in production, you're not going to have logging set to debug, right? You're going to have logging set to something like warning. So you really shouldn't be flooding your logs either in typical production.
Agree.
But that even being said, there's logs potentially are more than traces, maybe not. But I'm assuming because it's UDP here, it's best effort, and they're expecting losses under network load, and it's basically it's not important to get every trace. Hence, they do sampling anyway, right?
Yeah, but I think if they're using UDP, right, wouldn't it have another side effect? Let's say I don't have deployed the agent, and UD is just a connectionless and the file and forget, and it will keep on generating the network traffic, although there's nobody on the next end to receive it. Right, client would not get to know.
And again, it may be that we don't want to use this for logging. It's a fair decision.
Yeah, right.
Regardless of its use for logging, I think it has some value.
Yeah, definitely. I think for the tracing part, we definitely have to identify which part of the system is taking time and becoming important, specifically in load scenario.
Okay. We're well over the time allocated for the meeting. So I wanted to thank Hung Wei for the presentation, and I think do we have a plan or a suggestion of how we want to proceed with integrating this into Volta?
Yeah.
Okay. Let's I think it's worth exploring that and maybe coming up with a proposal for that. I don't have anything else on the agenda, so I'm going to end the meeting. If there are other things people would like to add to future agendas, please email me, and or hit me up on Slack, and I can do that. And with that, thank you all for joining the meeting. I'll talk to everyone next week.
Thank you.
Bye, everyone.
Bye,
Bye, everyone.
Thanks. Bye.
Bye.
Bye.